about methane. Oh, okay, hold on. I just got the recording in progress here. Okay, so I should tell you what it's all about, why it's important, and what it is. Okay, and it is also the second major component of the greenhouse gas, where carbon dioxide is the first one. And I should point out real quick that since we hear about the global warming and climate change, carbon dioxide accounts for about 65% of all the greenhouse gases. Methane accounts for 19%. And then we have the other gases such as CFCs and other chemicals. And I'll mention a few of those today, which actually help global warming. But methane is by far the second most abundant, but its impact is about between 25 and 85 times as great as carbon dioxide per molecule. And I'll go into that in a few minutes later on. Okay, so what I want to do is continue now. You all see one picture here, right? You only see one picture on the screen?
Right.
Because my other screen I see too. Good. This is the one you should be looking at. Okay, now here we see a bunch of cows. Here we see a bunch of them schmoozing with each other, and they're cute little animals, I guess. Now, what I want to show you first is something called the global methane budget. And this is in a unit called teragrams. A teragram, in other words, you have a bunch of grams, and they're 454 grams to a pound. So whenever you see the word tera, that means it's you have one followed by 15 zeros. So obviously that's a lot of methane. Okay, you have put a one, follow it by 15 zeros. That number of grams, you're talking millions of tons of methane. And here where a lot of the methane comes from: fossil fuel production, agriculture. This is where the cows come in. Biomass and biofuel burning. That means burning fuels, and biomass means wood, animal.
We lost David. Sound.
Oh, there. Can you hear me?
Yeah.
Yes, we could hear you now.
I don't know what happened. I got muted. Okay. Anyway, good. Keep telling me if I get muted, because I'm watching the screen here with you all, and then I have my other screen here. All right. So the wetlands is an area that's wet at least sometime in its life, like swamps and areas like that, and not all year round, though. And they also produce methane from bacteria, and actually rice growing is a large source of methane gas too. And so these are the main areas of methane production. But today we're going to talk about cows, because this is very important. But before I go into that, I want to show you what methane is, the formula. It's a very important substance, because everybody here deals with methane, especially in their kitchen. Those of you that have gas stoves, which I assume is most everybody, which is not the greatest thing to have, is methane. Now, those places such as these little trailers and things like this, where people live in trailer parks, they have tanks of butane, which is similar to methane. It just has a few more carbons than methane has. But regular cooking gas you have in your kitchen, supplied by the city or the state, is methane gas with this formula, CH4. Okay, so this is what methane is. And here we see various models. This is called a ball and stick model, space filling model, structural formula model, and just the empirical formula. So there are many ways of depicting this when you see formulas. And here we see a bunch of analogs of methane, because to me, methane is like the granddaddy of all organic chemicals, because a lot of chemicals come from it. Now, I just told you the formula of methane, but if you look here, you have dichloromethane. This is trichloromethane. And these are all refrigerants, okay? That the freons that they use in cars and in refrigerators and things like this. And CF12 is one of the worst. It's called difluoro, I'm sorry, yeah, it's called CF12 is that's the worst, difluorochloromethane, and it's a very bad one. Okay, that's this one, and this one is bad because it destroys the ozone layer. But well, some other lecture I'll talk about that. That's why we have to get rid of them. But anyway, these are just simple analogs. This is chloroform. I'm sure you heard of chloroform. That's the stuff that puts you to sleep. And then we have bromoform, and this is one of the main components in asparagopsis, and we'll show you how that works later on. I want to mention now that here are some other sources of methane, even though I told you previously. And the main one here, this shows you natural occurrences and anthropogenic sources. Anthropogenic means caused by humans. Hence, the study of mankind at a university is called anthropology. Now, if we look here, we see gas production. This comes from also oil extraction. Then we have coal mining, landfills. Landfills produce a lot of methane. Biomass burning. This is where they burn wood and paper and stuff like this. And as I mentioned earlier, rice paddies. Why is this considered human? Because we grow the rice paddies to feed the billions of people. We have around 7.8 billion people on the planet. And maybe one day I'll speak about that problem too. And now we're going to talk about ruminants. Ruminants are the cows that we're going to talk about. I'm going to give you a lot of information about these. Okay, so all these here in the lighter color are anthropogenic sources. Over here in the darker colors are the natural sources, and that includes termites, wetlands, ocean, water, and fresh water. And unfortunately, we have something that's deep down in the ocean called methane hydrates. This is where methane is trapped in ice. And now, with climate change, we have to really worry about this, because if the ice melts, the methane will be released, and it becomes a potent greenhouse gas. And again, I don't have time to talk about that now, but if you want, I have a lecture on YouTube about methane hydrates. Okay, so what I want to do today is talk about cows, but first I want to give you some more information on this. So what kind of physical chemical property does methane have? Methane essentially is a colorless, odorless, and highly flammable gas, and the main component in natural gas, which is what you have to heat your homes and cook with, okay? Now, methane accounted for roughly 10% of all human-driven greenhouse gas emissions in the US in the year 2017, according to the EPA, okay? Now, I just mentioned briefly about methane, but I want to mention a lot more about that in this section here, because this is really important. And we're going to deal with termites, okay, also. So I want to read this to you, even though I repeat myself. And by the way, people ask me, why do I repeat myself? Because the answer is very simple. In addition to the Chevy Bolt I drive, I also drive a Toyota Echo. So now you know why I repeat myself, because I have an Echo. Now you know why I repeat myself, because I have an Echo. But anyway, you get the idea. Okay. Anyway, so a form of methane mixed with ice is called methane gas hydrates. They can be found trapped in layers of sediment on the ocean floor and beneath permafrost. This is another issue we got to worry about. Permafrost is mainly found in the tundra region, and this is the soil that's frozen because it's very cold there, okay? And that's why you don't find trees up there in the tundra. The tundra is the northernmost part of the planet, other than the North Pole. You also have some tundra in the south area near the Antarctica, but not very close, but somewhat close. And the soil there is beginning to melt. And if the soil melts, we have another problem. We're going to release a lot of carbon dioxide, methane, and possibly pathogens, such as what happened a number of years ago. Anthrax bacillus, which is the bacterium, was released, and it was said that it killed a lot of reindeer up there. And they believe it happened because maybe the permafrost melted and the bacteria was sort of frozen maybe in a state of suspended animation, and then they got let loose when it warmed up and infected the reindeer. So these are serious problems. I don't want to scare you about it because at least we know the problem and we're probably going to work on solving it. Okay, now, these solid ice deposits have been touted as a potent energy source. Why? Because of the methane. Now, the only way, as far as I know, to get the methane is to burn it. And that literally burns me up because we're producing more carbon dioxide. I want to point out something. When you burn just a hydrocarbon, which means just hydrogen and carbon, you get two major products, water and carbon dioxide. So again, if we burn it, we're producing more carbon dioxide, and that's the stuff that we want to limit, okay? All right, so anyway, you get the idea. Now, according to the EPA, 50 to 65% of US methane emissions are related to human activity, while 30% of human-related emissions are released by natural gas and the petroleum industry. Now, here comes the big thing I want to talk to you about, because we're going to get to the cows in a few minutes there. Termites. Now, I know you know what termites are. Those of you who live in houses, in order to get maybe a certificate of occupancy or something like that, you need to make sure it has no termites in it because they like to eat wood, okay? But termites produce, you ready for this? 20 million tons of methane per year, okay? We have trillions and trillions of termites. Each one produces about a half a microgram of methane, okay, in their guts. I think that could be a day, not year. I have to check that, okay? And there are 454 million micrograms in a pound. So you multiply that by the number of tons, if either 2,000 pounds, but if this is a metric ton, it's 10% more. So a metric ton is equal to 2,200 pounds, whereas the short ton we have in America is 2,000 pounds. So again, we have to figure out, are we talking metric or short ton? And sometimes they don't say, so we should go with the most conservative one. So we're dealing with a lot of grams here, okay? And the reason why that happens is because you have an organism called a protist, which is trichonympha, which means it's a single-celled organism, and they convert the wood into starch and sugars, and they produce methane. Here we see the trichonema. It's a single-celled organism found in the gut of the termite, and here we see some termites having a happy time living under the ground. Now, how bad is methane for the environment? If you can see this picture here, let me try to blow it up a little bit. I guess it's not working. So anyway, you can see this. This has to do with global warming. And I have some numbers here. I just want to briefly mention them to you. Here we have carbon dioxide. Carbon dioxide makes up about 64% of the greenhouse gases, and it has a global warming potential of 1. Global warming potential means the amount, how it heats up the environment, okay? Carbon dioxide, since it's the main culprit, we give it a number 1. You see these other numbers here, such as methane, the number accounts for 19%. That has a global warming potential of between 21 and 85 times. And what that means is it heats up the environment that many more times compared to carbon dioxide. Then we have nitrous oxide, which is also called laughing gas. It's one of the NOxes, and NOx is one of the oxides of nitrogen that we deal with, and that has 310 times the global warming capacity. Then we have the CFCs, and this is the main one, the chlorofluorocarbons, which have been known to destroy the ozone layer by taking away the chlorine, and that takes away an oxygen. And I should speak about that possibly sometime. As a matter of fact, the one who discovered that, a fellow named Mario Molina, and 2 of his colleagues, whom I've actually met. I met Mario once, and he just died last year at the age of 77. He won the Nobel Prize, I believe it was in 95 or somewhere around that time, for discovering how ozone gets destroyed by the chlorofluorocarbons. And as you see here, we have, it's about 1,300 to 12,000 times the GWP, which means if we take the most conservative number, highest number, over 12,000 times, that means that's how many times methane heats up the atmosphere. And then we have the perfluorocarbons. These contain fluorine. These are special substances, okay? They're used in semiconductors and things like this, between 7 and 12,000 or 13,000 times. And then the granddaddy of them all, and believe it or not, we're still using it, is sulfur hexafluoride with a GWP, global warming potential, of almost 23,000 times. So fortunately, we do not produce a lot of this. I think it was 6,000 tons, but 6,000 tons which are released is quite a bit. But so fortunately, methane does not come close, but still it's a problem. If methane had a GWP of this much, I believe we would be cooked by now. Now, I believe I want to tell you about cows, and that reminds me of a expression, to err is human, to moo is bovine. I thought that was something that I got. All right, now, I want to tell you what a ruminant is, and now we're going to be talking about these. A ruminant is an even-toed, hoofed, four-legged mammal that eats grass and other plants. And by the way, I'm going to show you a couple movies on this. They're animations, don't worry, they're not 3-hour epics, and I think you will enjoy them to explain further because they can say better than I can. So ruminants include cattle such as cows, sheep, goats, bison. By the way, those of you that have a son, every time you see him and you have to go somewhere, you say, bye, son, see you later. All right, anyway, then we have deer. By the way, speaking of deer, did you hear they found a building in Chicago with a lot of deer in it? Did you know that? Yeah, it was called the post office. Dear John, dear Mary, dear occupant. Anyway, all right. Anyway, then we have cantaloupes. I don't know if they like, I mean, antelopes, if they eat cantaloupes. But anyway, then we have giraffes and camels. Ruminants refer to rechewing the cud to break down the plant matter further and stimulate digestion. And this is called rumination. Now, I've heard that term when someone's thinking, hey, Joe, are you ruminating? No, you hear that expression sometimes, but I doubt they mean he's chewing his cud. All right. Now, how many cows are there in the world? Okay, there's quite a few, actually. The global cattle population amounted to about 1 billion head in 2021, up from approximately 989 million in 2020. Wow. And one thing about the cows, this really annoys me, is the fact that they have to cut down the trees, especially in the rainforest, especially the Amazon, which I love a lot because I happen to be there. I was there in 2017 to see for myself, although most of it was there. And at that time, 80% of the forest is still there, that you should know. So that's sort of a good thing. They cut down the trees to raise cows because cows give you a lot of money, okay, when they raise it, because people have an addiction to meat. And you got to ask, why do people have an addiction to meat? You must admit, most people like to go eat a steak, even though it's not the healthiest for you. And the reason they believe why we all like steaks, or most of us do, except for the vegans and vegetarians, is because it has to do through evolution. That's how we developed a taste for this. Now, this is a theory that makes sense, and I didn't make it up, okay? So this is one of the real reasons why we like meat. You know, why do we like anything? Because we're used to it, and our ancestors like it, and that's why a lot of these steakhouses are in business all over the world. Now, how much methane does agriculture produce? Okay, here we see a 500 kilogram beef animal. Now, a kilogram is equal to 2.206 pounds, okay? So they weigh a lot, okay? So you multiply 2.2 roughly times the number of pounds, and that tells you, I mean, yeah, how many pounds. In other words, a kilogram is 2.2, okay? Actually, that's really a good thing in a way, because let's say you're a person that weighs 100, you weigh 220 pounds in America, You go to Europe where they do the metric system, you only weigh 100. So you knock off 120 right off the bat, you see? So at least psychologically, it might make you feel better. So anyway, let me read this to you. A 500 kilogram beef animal on a high concentrate diet produces 230 grams of methane per day, which is a little over half a pound, okay? Half a pound of methane per day, all right? Now, on pasture, they emit about 320 to 330 grams, which is over half a pound. Put another way, they can produce 250 to 500 liters a day. And it comes from the mouth. They belch it, okay? It's a burp. And they found out that there are more burps than through the other end. And by the way, someone asked me, said, Dave, do you know the color of a burp? I say, yeah, it's purple. But anyway, you get the idea. Okay. Now, each year, that's about, each year they produce 220 pounds, which is 100 kilograms of methane. Remember, there are 454 grams per pound. So I don't know if that's right. That's right. Anyway, humans produce between a half a liter and 1.5 liters per day. Now, here we see the anatomy of a cow or ruminant. It's probably similar to other things such as goats, sheep, camels. And I'm going to play a movie for you on it. But here we see the burps. And here we see the large intestine. We have the rumen here. You have a reticulum. You have an omasum, abomasum, and small intestine. So these are the main parts of the cow's digestive system. So I should, and in the digestive system, you have bacteria. And these are bacteria taken with the scanning electron microscope, okay? Bacteria which produce methane are called methanogenic. They use the word genic from the first book of the Bible, Genesis, okay? We have carcinogenic, which means unfortunately making cancer, angiogenic, producing veins, and methanogenic, and we use this term genic a lot, and it means the production of, okay? So methanogenic bacteria live in the gut, and they are responsible for the methane. And I cover microscopy a lot in my classes. So, you know, I have them identify what kind of microscopes took the picture, because as we approach the year 3000, we have new technology. So this looks three-dimensional, and this is what they look like. And this is a result of a scanning electron microscope. Okay. All right. I just thought I'd point that out. Now, one of the main species of the bacteria is Methanobacterium ruminatum. Okay. And so that's a good one. Now, what I'm going to do is play a movie for you and show you, this is a couple-minute movie. It explains about digestion. Yeah.
Unlike humans, all grass-eating animals.
Hold on. Can you hear it loud?
Yeah.
It's clear? Okay. Everybody hears it. I just want to make sure.
Have a special stomach with 4 chambers, namely rumen, reticulum, omasum, and abomasum. Let's see the process of digestion in grass-eating animals. The animals quickly swallow the grass and store it in rumen, the first chamber of the stomach. In the rumen, the food gets partially digested. The partially digested food is called cud. The cud is pushed into the reticulum, the second chamber of the stomach, and from here it is sent back into the mouth for thorough chewing. The process of chewing the cud is called rumination, and animals which chew the cud are called ruminants. The rechewed food is swallowed and sent into the omasum, the third and the smallest chamber of the stomach, to absorb excess water from the food. In the omasum, the food is broken down to even smaller pieces. This is then sent to the last chamber, abomasum, which is also called the true stomach. The digested food then goes into the small intestine, where absorption of nutrients takes place. A large sac-like structure called cecum, present between the small intestine and large intestine, also contain bacteria that help in the digestion of cellulose, a carbohydrate that is present in grass. So, you now know why cattle keep chewing all the time.
Yeah, so get the idea there. That makes it pretty clear. All right, let's go to the, okay, now, I have another one that you should watch, and this has to do with the burps. And notice the formula for methane, CH4. It's a real simple one. By the way, that remind me, I had a teacher when I was in graduate school. His name was Harold Romer, and he was actually the assistant air commissioner of New York City. So he taught us the environmental pollution class, and he gave me his home phone number, which was quite unique in those days. So I would call him and talk to him, and his number was CH4 something. I remember that. It was easy. That's where it began, something like that. I said, well, actually, I said methane 4286 or something. It's pretty cool. So that's how I would remember. But anyway, so let's watch this one. And I think you would enjoy this. And this is by a professor talking about methane. I mean, this is another, I'm sorry. This is another animation which
Thanks to
goes into
Curiosity Stream for
more
supporting
detail.
PBS Digital Studios. If you grew up in suburbia like me, you might not have ever considered the fact that cows are pretty gassy creatures. Just ask the German farmer who in 2014 had to deal with a slight exploding shed problem thanks to his dairy cattle's burps. Turns out the thing that exploded was methane, aka the natural gas you might use to cook your food. And Bessie over here can belch up something like 200 to 600 liters of the stuff every single day. Methane is a product of the crazy digestive system cows have with 4 stomachs. Stomach number 1 is called the rumen, and it's home to a microbe zoo. From protozoans to archaeans, you can find practically every major kind of life in there. Why? Cellulose, the carbohydrate that makes plants tough and fibrous, is technically impossible for the cow to digest on its own, which is why it needs the help of all those little microbe friends. Some of them.
I'm going to continue. I just want to tell you, he mentioned the word archaeans. There are 2 types of bacteria, the eubacteria and the archaebacteria. The archaebacteria are the ones also known as extremophiles, and they have a different cell wall structure than the regular bacteria, just so you know what they are. I want to interrupt you here just so I don't forget to tell you, because he mentioned archaeans. And so these are, again, they're extremophilic, which means they live in incredibly bad environments that humans can't tolerate. Too hot, too cold, too salty, too much pressure, things like this. Okay, I just wanted to cover that. All right,
Take the cellulose and break it down into less complex molecules that the cows can then digest. The microbes release hydrogen gas and carbon dioxide as waste products. That hydrogen gas, if it were allowed to build up, could interfere with further digestion. So another group of microbes called methanogens take the hydrogen, react it with the carbon dioxide, and produce methane. The cow can't use the methane, so it just burps it out. Improperly ventilated barns aside, the real reason to be worried about cow burps is that the methane is a nasty greenhouse gas. Over a period of 100 years, 1 kilogram of methane could potentially warm the earth about 28 times as much as a kilogram of carbon dioxide. And cows, along with other livestock, emit many, many kilograms of methane from their burps. About this many in 2007. That's enough to make up about 7% of all greenhouse gases emitted by human activities. The planet is paying a high price for our burgers and shakes. So what can we do to save us from ourselves? Well, there are a couple of options. Either cut down the amount of methane the cows produce in the first place, or find a way to capture and use it. People are experimenting with adorable little backpacks to collect cows' gassy emissions, but it's probably more efficient to stop the burps in the first place. And scientists have tried pretty much everything with mixed results. One approach has been to vaccinate the cows against their own gut microbes, persuading their immune system to straight up murder those methanogens. Researchers have also supplemented cows' feed with essential oils like garlic, peppermint, and eucalyptus to aid their digestion. And because the amount of methane a cow produces seems to be inherited, some researchers are on the hunt for a breeding fix, breathalyzing cows to see who's got the least methane on their breath and sending those clean ones off to have babies. So there's no shortage of creative solutions once we actually put them into action. Until then, enjoy your gassy half pints and exploding barns. Curiosity Stream is a subscription stream.
By the way, I subscribe to Curiosity Stream. You only pay something like $2 and something cents a month. It's real good. They have hundreds or thousands of documentaries and in all subjects. It's pretty cool. All right, now. Okay. Now I want to get to the Asparagopsis. All right. By the way, feeding cows seaweed could solve the bovine burp problem. And I don't know how they come up with this idea, but it was brilliant. There are three basic types of seaweeds. We have brown, green, and red. And this one is a member of the red seaweed. And if you would look at the stratification in the oceans of the seaweeds, the upper level is green, the middle is brown, and below that is the red. And that has something to do with the pigmentation and how it perceives light, okay? And red, by the way, is the first wavelength absorbed by the sun in the ocean. And anyway, we'll discuss this maybe at a different time, why red is sort of the deepest. Now, these are not tremendously deep. You still need some sunshine. But anyway, this is the stratification of this. And by the way, when we go outside in March and April, you will all see weeds. Just thought I'd mention. All right, now, methane spewing cow emissions are killing the planet, but a meal sprinkled with Asparagopsis taxiformis, which is what you see here, could make livestock less gassy. Now, here's the incredible part. It was found that a diet of just 1% of this seaweed produces 50% less methane. And as you're going to see, as I'm going to tell you later, there's even higher percentage when they do in vitro studies. In vitro means they do it in a lab. Hence the term vitro comes from the word glass. And so that's where they did it, in test tubes and beakers and things like this. And so when they do experiments, like even when you see with pregnancy, they do in vitro or in utero. In utero means they put the embryo in a real uterus, whereas they do in vitro fertilization. They fertilize an egg, either in a petri dish or some other area outside of a human, okay? So in vitro means glass. It comes from, I believe, the French word for glass. Now, they also found out that if you're worried about the milk, they found out that through 25 testers, these are people who tasted the milk between cows fed the regular diet and those fed diet with seaweed, there was no perceivable difference. You understand? Okay. Yep. So that's very important because maybe people wouldn't want it. And so really, I mean, we have a gold mine here. The only thing is we don't want to overfish or I guess over harvest the seaweeds, because then there's not going to be any left. They may have to grow it. All right. All right. Now, how does Asparagopsis work its magic? I'm going to show you that now. And again, by sheer coincidence, it has to do with an analog of methane. What a coincidence, called bromoform. And that has the formula CHBr3. So let's see how this does it. In vitro experiments, remember, that's done outside of the animal, showed that Asparagopsis taxiformis reduces ruminant enteric methane, that means coming from the digestive system, up to 90%. How does it do it? Well, the magic is performed by bromoform, that's CHBr3. Again, this could also be called tribromomethane, okay? You can call this many things, but the technical name is 1,1,1 tribromomethane. The 1,1,1 means what carbon are the three atoms of methane, but that's in organic chemistry, which I happen to like a lot. So, but we'll just use the simple form, bromoform. It's similar to chloroform. Chloroform is, instead of having bromine, has chlorine. You understand?
Yep.
And so these are analogs of methane. Like I said, okay, this is a compound in seaweed that protects them from bacterial infection. So what happens is, how they found this out, I don't know, but they do it. That's why we have science. In cow stomachs, the bromoform reacts with vitamin B12 to stop methane producing bacteria from completing the last step in the creation of the gas. Isn't that amazing? Now, I'm going to show you a movie on using this. And by the way, look at all this technology here to make even this slide. This was done automatically by the program. They're pretty smart, PowerPoint. All right, now I'm going to play this movie for you. Let me see if we can get it going here.
Ripping cows
I
trying
got
to
it.
diet.
Yeah. Let me put this. There we go. This
Seaweed is an amazing resource.
tells you
It
about
is
the
something
seaweed.
That we call a superfood. It has an order of magnitude more vitamins and minerals than any leafy green that we can grow on the planet. And it's vastly underutilized here in the US.
But this underused algae isn't just for humans. Researchers are studying a specific kind of seaweed to feed to cows.
We've been working on trying to expand an industry for seaweed consumption by humans and came across some research about this red seaweed Asparaginus taxiformis. As I started reading more about that research, I became really excited about it because it has the potential to dramatically reduce methane emissions across the
I don't know
planet.
who's sneezing. Oh, I thought that was the cow. Sorry, Lenny.
Inside science.
I thought that was on the video.
Methane is a powerful greenhouse gas that can be emitted during production of coal, natural gas, and oil. But it also comes from this. One of the greatest sources of methane emissions on the planet is belching cows.
95% of the methane that cows produce comes out of their mouth, not the other end, unlike what most people might think.
In fact, it's a greenhouse gas that is 30 times more potent than CO2. Now, researchers say this red-colored seaweed could help reduce the methane cows burp out. The seaweed contains compounds that stop the production of methane during the digestion process. Adding a small amount of seaweed to cattle feed has the potential to cut methane produced by the animals by more than 50%.
When cows aren't producing as much methane, they're actually able to use their food resources more efficiently, so they can actually digest more of their food rather than just burping it out.
Researchers say the seaweed is intended to be added to the cow's diet as a supplement.
We're not going to be able to feed cows bales of seaweed. We're not going to replace their grain diet with seaweed.
According to Smith, many farmers are on board with the idea of seaweed supplements for cows.
I've talked to a number of livestock farmers around the country, actually, and people are really interested in this as a potential methane mitigating solution. To think about in 10 years that we could be going past a dairy farm and to think that we helped reduce methane emissions in those cows by 70%. In my lifetime, we'll be able to see the reductions in greenhouse gas emissions because of this.
So pretty cool. So they're doing a lot of research on this. So when scientists get together, we can actually solve the problem if we keep the politicians out of it. Okay, now there's a story about this. I should tell you, cows and milk. You know, everybody knows I'm involved with the environment and health and all this stuff, environmental health. And one day I get a phone call from a friend of mine. He lives in Wisconsin. His name is Joe. I think all my friends are named Joe. He says, "Hey, Arieti, I got this problem. You know, I have this dairy farm, and for the last 2 weeks, my cows stopped giving milk." I said, "They did?" He says, "Yes." I say, "Well, look, did you have the EPA and Department of Agriculture come out and check the air, the food, and the water that you're giving them?" He said, "Yeah." So I said, "What are the results?" Well, he said the air seemed to be okay. The food, which was the hay we gave them, was okay. And the water was okay. So I said, "Well, let me get this straight. You say they haven't given you milk for 2 weeks. The air was okay. The water was okay. And the food was okay. That means there must be an other reason." Okay.
Gee.
All right.
Oh,
Anyway.
God.
Okay. Just so I mentioned that. Now, one more thing. I got this picture. It has nothing to do with today's lecture, but I thought it's a pretty one. You see a little house here in the middle of a little pond, and this obviously takes place in the autumn. So anyway, that's all I have to say. Now, does anybody have any questions, comments, anything? Yes, sir, Lee, go ahead.
Ma'am, I think it is.
Oh, man, yeah, right, good point.
So the question is the harvesting of this red seaweed scalable?
Yeah, because I assume it is, because seaweeds grow. If you've ever seen seaweeds, now I grew up in the Atlantic coast, you know, in New York, and during certain seasons, man, you got tons of it out there, and it clogs up engines and stuff like this, you know, boats. So now, as for the red seaweed, I don't think we have the let me see where Asparagopsis comes from. I don't think we have it up north where I'm from. but it's probably in the lower areas. Let me check. Where is it grown? Because I'll check that out because
No, you gotta shade more.
So when you say grown, do you mean farmed and produced on a you know,
yeah,
grown
I
on
mean,
purpose?
good
Or where does it
question.
appear
no,
naturally?
I meant both places, right? I'm looking for natural sources. I'm looking it up now. Where does, you ask a good question. I never thought of that because I was, but you told me, very good. Where does escarab grow? Here, I'm putting it on here. Let's find it. Let's see. Most scientists have focused on one red seaweed as it thrives. That's what I thought. It says it thrives. Here, I'll show you right now.
Yeah.
It thrives in tropical and subtropical climates, okay?
Yeah.
And it can be found in Southern California. But it says here, the habitat in the US is relatively small since it's warm water species. So it mainly grows in warm water. So you have a good point that we got to worry about over harvesting. That's essentially your question, right, Lee?
Well, over harvesting or just getting it to grow more if we're going to use a
Yeah.
lot more.
Well, if that's the case, actually now with other seaweeds, and I assume it's this one, I don't know exactly, but they do grow it as a
Yeah.
crop.
Yeah,
And you
yeah.
see the stuff nori and all this that they put in,
Sure.
Red seaweed.
you know, sushi and all this stuff where they
Right.
wrap. And you saw a picture of it in the movie where they have rice, and I think that was nori, it's the green seaweed. They wrap it in, and
Right.
I'm glad you asked me that. I will research that out. But it's mainly a warm water, just like I suspected. And actually in Wikipedia, now, by the way, I want to point out something about Wikipedia. Wikipedia, a lot of people don't like it, but I love it. So far, I haven't found any errors or any incorrect things about it. Okay. By the way, something real interesting about Wikipedia, I should praise them for two reasons. One, to have my father mentioned in there, and also his book called Interpretation of Schizophrenia has its own page. I just thought I'd mention it, but so I like Wikipedia for many reasons, and I think for the
Better,
most,
much better, honey.
David,
yes,
Yeah, go
David?
make your lunch.
I have
Okay.
I have a question. If people use it as a supplement, then what is the financial benefit for a farmer to actually use this? Will it improve the health of because a lot of people won't do it just to help the environment. You know, there's
right.
the,
No, evidently, from the literature, it seems to help the cow because, as the lady scientist said, it devotes more. I'm glad you asked that. I should have mentioned that see, methane, to produce the methane takes a lot of energy inside the body. Okay, you know, if you study biochemistry and stuff like this, the body needs energy to function. So this actually reduces the amount of energy. So as she said in the video, that the extra energy can be used to making more nutrients for the cow. So it's
More
actually,
efficient
according to
digestion.
what she says, it's healthier because most of the effort is being made for nutrients and not to produce the gas. Don't forget, everything in your body needs energy to produce, right? So, and now, you know, for some reason, nature made methane as a product of digestion. But if you can reduce it, and that's probably less harmful to the cow, because if you have a lot of gas inside the cow, it obviously causes, you know, maybe bloating and things like this. I assume, that's what I'm assuming. It's probably healthier for the cow, but you ask a good question. I have to look that up, but based on what she says, she said it was healthier. That's the only answer I can give you. I don't know 100%. I don't want to lie to you, but
Thank you.
Oh, you're welcome.
Any other questions for David?
Hey, I have one more for you all. Why do cows have bells? Because their horns don't work. Just thought I mentioned. All right. By the way, one more thing you should know about cows. The reason why most cows are poor because farmers milk them dry. Just thought I mentioned. Hey, any other questions, comments?
Yes, David.
Paulette, yeah, go ahead.
Paulette has a question.
Yeah.
I'm going to read you something. 2,000 years ago, a spontaneous mutation in Northern Europe, cows changed the type of protein, their milk, from casein A2 to A1.
Right.
This milk causes inflammation and likely a cause of type 1 diabetes.
Ah.
But products made from goats, sheep, and water buffalo are not affected. Good news, cows in Switzerland, France, and Italy have casein A2.
Wait, did you say the casein A2 is better?
Yes,
Yeah, here, I just looked it up while you were talking. Here is some of the stuff. It says here, the health effects of milk may depend on the breed of cow. Very good. You see that, Paulette, up here?
yeah,
Just looked it up. It says
Yeah.
components of
I've been
certain.
buying A2 milk for a year or two, several years now. And it
Really?
does have,
Where
it
do
comes
you
from
get that?
Guernsey cows. I
Yeah, where'd you
think.
get it?
You can get it at Walmart, you can get it at Mariano's, you can get it at Jewel, you can get it, anywhere just about.
But it's labeled as A2, like how,
It has a big A2 on it. It's the brand name even. It's so
really?
easy to find.
Wow.
Wow.
How'd you hear
Part of
about
my
that, Lay?
anti-inflammatory diet.
Well, how'd you hear
Wow.
about that, Lay? I
My
never heard
sister
of it.
told me.
Oh, wow.
She's on the
Look.
keto diet. I'm not on that.
Oh, so here it is, the information. The A1 beta casein comes from breeds of cows that originated in Northern Europe, is generally high in A1 beta casein. These breeds include Holstein, Ayrshire, Friesian, etc. Here, A2 is betaine casein, beta casein, milk that is high in A2 beta casein is mainly found in breeds that originated in the Channel Islands and southern France. These include Guernsey, Jersey, Charlotte, and Limousin. Wow, that's pretty cool. So you take A2, you said?
I've been using A2 milk. Yeah.
By the way, that reminds me of a story about a Jersey cow. This guy got into an accident, and it was a son of his father. And well, of course, all men are sons. But anyway, the father comes by and he sees his son in a car wreck, and he says, "Son, what happened to you?" He says, "Well, I hit a cow." So the farmer said. So the father said, "Was it a Jersey cow?" He says, "I don't know. I didn't see his license."
Yeah.
Anyway,
but I
Right.
want to tell you, this is a book that I read called The Longevity Paradox, How to Die Young at a Ripe Old Age.
right.
And it's written by Dr. Stephen Gundry, and he was a heart surgeon for 25 years now. He's an internist helping people with diet. And he said that once you pass infancy, like 1 or 2 years old, there's no need to drink milk. Milk is only to feed calves so that they grow 20 pounds a day or something like that. So his thing is you could drink almond milk, you could drink coconut milk, but as far as you adults and humans, we shouldn't be drinking milk anymore.
Yeah, I heard that too. So I don't, wait, Pete wants to say something. Go ahead. Yeah, Pete, did you want to say something?
Well, there is a lot of rationale for that, truly. You know, if you look at diet and health and holistically, so to speak, I think there is a lot of rationale for that. And, you know, I don't know myself, I'll put some milk in my coffee and that kind of thing. But, you know, my days of getting that huge, you know, Culver's triple size, you know, chocolate milkshake with a with a codfish sandwich are probably long gone. So that being said, you know, a conversation David and I had about this topic is and one of your pie graphs reflected that real well, is if you just look at, you know, a broad swath of the food productivity and the plant productivity on the planet and the need of people to eat, you know, I think it's safe to say to eat better foods. We can't ignore that the cows themselves really represent what an opportunity to convert grass to human food. Okay, so to have that intermediate, and that being said, if you look back at that pie graph about where the ruminants were, and in that sense it was all anthropogenic, but if we cut out all of the herds of cows And the buffalo came back, well, they'll just be doing what the cows did. Okay, so, of course, you won't have feedlots and the various
the
other
corn
things that go
production.
along with that, and all the methane that comes out of that. And, you know, so I'm sorry, I kind of went off into all of that, but I think, you know, David, you know, reflects real well that every element of this, it just gets into something big that touches on so many other things. And when you talk about human food production, then it, you know, you get into some whole scope of all the cultural practices and things like that. So, yeah, that was, but yeah, we want to thank David though for weaving us through this complicated topic and diving into some of the real reasons why it exists and why there are controversies with this and why the science of it can help to get our society through this. And whatever happens to the hamburgers and steaks and the, you know, the gallons of ice cream and all the other things, I think is something that will have to evolve, you know, over time.
Yeah,
But
I
we
was,
definitely make the lives of the food animals much better and make the pollution byproducts more minimal and mitigated.
I want to say something about the milk too. This is why I believe, you know, we have a lot of people who are lactose intolerant
Right.
and they
Right.
can't drink the regular milk. I think Africa has a large population of lactose intolerant people. And that could be because, you know, as Pete said, the purpose of cow's milk is to feed baby cows, not baby humans, you know, as a rule. But we're just used to it because it's simpler and quicker and easier to get. And
I think if you look at the world's population, the majority of the world's population is lactose intolerant.
yeah, that could be. By the way, I wanted to ask you, Lee, how much more does the A2 milk cost?
It
compared-
costs more. I buy a half gallon, which is really only 59 ounces, and it's typically $4 to $5.
Yeah, because I always get I try to get the organic milk no matter what. And it costs between $3 and $5, but it's healthier for you. You know, I don't drink that much, so it's not, considering you could pay just $1.50 for the same amount of regular milk like Dean's, which isn't the organic stuff. And oh, by the way, I want to point out something else. In May, I'm going to speak about toxic algal blooms, which has become a real problem now. And Pete and I are writing a book about algae now, too. And a great part of it has to do with the toxicity of algae. And you know, so I think you'd be interested in that. I think that's May 1st, right? Or May 6th, something like that. Jenny, what do you think? Jennifer? I think it's the 6th or somewhere in May. So it's quite a while from now.
May 1st, I believe.
May 1st,
David.
yeah. That's May Day, May Day.
Right,
Yeah,
right.
well, that will be May Day for the planet if we keep having all these blooms. Anyway, does anyone else have any comments, anything, questions? And you can always call me and I'm happy to do this. I love doing it. And by the way, I learned a lot today too. Oh, by the way, Larry wants to say something.
Yes.
David, I thought that was a very moving presentation. And just like a farmer, you're outstanding in your fields.
Like a what? A harbor? Oh, I mean a cow. Is that what you
2
said?
puns.
That's
Oh,
right.
very good.
And,
Well-
and with that, we would like to thank everyone for coming.
Yeah, thank you all. Yep.
Thank you, David, for a wonderful
Thanks, David.
presentation. I think we've all learned something, and I'm anxious to learn more. So thank you very much, and thanks everyone for coming.
Great job,
David.
Thank you.
Thank you.
Bye-bye.
See you all. Adios, amigos. Good broken Spanish.